Hello, and welcome to Mr. Jackson's class for physics, okay? We were talking about electrostatics this week. We've been going over that, and we've been talking about, our positive and negative charges. Our electrons are the ones that do the moving. So remember, when something is made negative, it's because electrons are moving onto that object. Things that are positive is because electrons have left the object, and the protons now left behind are greater in number. So it's the electrons that make positive and negative charges, which is kind of unique. And neutral objects are where the electrons and positives are equal. So let's move on from there, and let's talk about how we can get objects charged. So we're going to talk about the three types of charges, and the three types ways to make objects charged. They are by friction, conduction, and induction. But I'm going to jump to a bigger sheet of paper so I can write some more notes and make some more pictures. But we'll come back to these if you need to stop and write these down. Or on the other picture, you can stop and write down the notes, okay? So let's jump to this other sheet of paper here. And I've got them defined out a little bit better. Here we go. We have friction. Friction is when we rub two objects together. So that's a pretty simple idea. What happens is if I take and rub my hair with a balloon, then what happens is that objects, they both become charged. So let's take this balloon. Here we go. We got this balloon, and we got our hair. Okay. And as you rub your hair on the balloon, you end up giving electrons to the balloon, so it becomes negative. And then your hair becomes positive. And so individual strands of hair, as they become positive, will actually stick up on people's hair because the positive charges are repelling each other. So you can see people when they have static charge, their hair kind of sticks up. But what friction does is it creates two oppositely charged objects. So one object is negative and the other object is positive overall. And so when they get near each other, sometimes they'll spark and jump across. So objects that pick up a positive or negative charge now are statically charged. So friction creates two oppositely charged objects. That's pretty simple to do and understand. The next way to get an object charged, or two objects charged, is through conduction. Conduction is when two objects touch each other. So let's say I have a charged object, like a rod. You take a ruler and even this balloon, and you rub it on something like cloth or whatever, like a comb. You comb your hair. This comb, if this is a comb, it's something plastic, can pick up negative charges. Okay? And if you bring it towards something, well, what happens is those charges do not like being gathered together. They repel, just like these positive charges do. And so if you bring it to something that actually can take that charge, what will happen is you touch these two objects. So you bring that in there and you touch that. What's going to happen is these repelling electrons will jump off, not all of them, but some of them will because of the pressure of repulsion, and they'll go on. And so then this object will now have less of a charge, and this object will also have a slight charge. So this charge, let's say for example, it's plus 8. Or minus 8. Well, then what's going to happen is this will end up being minus 4 and minus 4 because they repel and they both get the same charge. So conduction is when two objects get the same charge because you touch them together. Okay? So this negative 8 was transferred, so now you got a negative 4 and a negative 4. What's happened is it's pushed it off. Okay? So both get the same charge. To go on and talk about the next kind of charging, I got to stop for a second and talk about what is an electroscope. An electroscope is a device that you have a conductive material like a rod, okay, and mine look like this. I have a rod and it goes down and it hangs on the bottom, and these little leaves are called leaves. They are very light material like aluminum foil, and they are conductive. And when you bring a charge, now a electroscope, it's a charge detector. So if I brought this negative rod near it, okay, what would happen is the negatives in this conductive rod would run away as far as they can get because they don't like it, and so then the positives would be exposed, but they would actually run way down here. And the more that run down there, the more they repel. If this foil is light enough, they'll actually tip and go outward away from each other. So that's how an electroscope works. These foil leaves, which could be any kind of metal, will swing out in a way every time they detect a charge at the top area of electroscopes. Okay, so let's define that. We have that as part of our notes right here. What is an electroscope and how does it work? It is a device that detects charges. And how it works is it is made up as a conductor, okay? And the conductor allows whatever charge you have to be movable or move around inside that material and force that charge to the leaves. And when the leaves move, it means that the object you're bringing near it has a charge. Now, you don't know what the charge is, you just know it has a charge, because if you brought a negative, or this was a negative one, where these got negative, let's bring a positive charge. So let's say we have a bar, and we have our electroscope here, and it has its leaves. Okay, if you brought a positively charged, where you've taken away electrons from something, and you bring it this way, then the electrons like that, they're mobile, so the electrons run up near this thing because they're attracted to each other. These positives get exposed, and then these get left because the electrons run up to be by these, and so now these are the same charge, and so they repel again and they move outward. Okay, and so the same thing will happen whether you have a negative or a positive. So we don't know unless we've actually put a charge that we do know. Okay, they just actually detect charges. Okay, so here we go. This is what an electroscope is and does. So with that in mind, we need to define one more thing, and that is grounding. What is grounding? Grounding is when a charged object is brought near the earth and it neutralizes it. Either electrons go on or off, but basically the earth balances the charges and makes things neutral. So if you brought an object near the earth that had a negative charge, so if I had something like this, let's say we had a negative rod, okay, and you bring it near the earth and you touch it, they can jump off and it spreads all around the earth. So the earth is either good at absorbing extra negative charges or taking and adding electrons to an object and making it neutral. So it neutralizes objects. That's what the earth does. That's why on all houses you have those little receptacles, and in a house circuit you see a big open, a longer one and a smaller one, and a small little like mouth on your outlet. The long one is the positive one, the short one's the negative, and then this is a ground. So if any extra current gets caught up from rubbing through your circuit, it can escape through here, and then outside of your house, outside of where your power box is at, which could be in the basement or the garage, there's a wire going out into a big old copper spike that goes down into the earth. And so if there's any excess charge in your home, it can escape and go out and into the ground. So every house has it, and all of these parts of your plug-ins in your house are attached to that copper pipe. So it helps get rid of any excess charge so electronic equipment don't get destroyed, okay? So grounding. So now, with knowing what electroscope is and grounding, I can explain induction better, okay? So what is induction? Induction is when you charge an object opposite to the charge you have, but you use grounding, and you never touch the two objects together. There's no touching. So here's what happens. Okay, you bring, let's say we have a negative charged rod, okay, or a balloon. Okay, doesn't matter what it is, and we bring it near our electroscope or something that is conductive. Okay, I'm going to use electroscope. And as you bring the negative one near, the electrons don't like it, so they run over here and they run down here. So your positives get exposed over here because they like it. But anyway, what happens now is I come in, I'm not going to touch these. There's no touching between these two objects. But I come in and I touch this side right here with my hand. And what happens is, since I'm touching the ground, these extra electrons that are being bunched together don't like being bunched together. They run out through my finger and my body, and it's a light charge, and it runs to the earth. So what I do is I ground this side and let the excess charge go off. Well, there really was an excess charge. There's a balance. There's the same number of protons and electrons. Since electrons left, now the protons on this are greater than the electrons, because this never gave it electrons. It came near, but they did not touch. They did not transfer. This charge is still the same. So I have stolen electrons because they think they need to leave because of this object. So then I remove my hand, okay, and then I pull this away, and now what happens is the leaves, because the electrons go back to where they wanted to go, well, now because of induction, this has picked up a positive charge because these negatives go back up here and they spread back out evenly, but there is more protons left behind, so there's an overall positive charge because extra ones left that thought they were too crowded together. So what is happening is these leaves now go out. So I have taken a negative object but created a positively charged one. So that's what induction is. Induction requires grounding. So the object that gets charged grounds, so either electrons are moving away or on, depending on what this is. And then you get an overall new charge on this object from the grounding because this one gave you the opposite charge. So this negative makes it positive. If this was positive, it would make it negative. Okay? That's called induction grounding. Okay? And it works through grounding of the material to the earth, and it helps move away charges. So it's kind of a little bit tougher to think about. Okay? So those are the ideas we wanted to bring to you, but we have one more idea we need to teach, and that is called Coulomb's law. Coulomb's law is a mathematical equation, and it is called F equals K, Q1 and Q2 over R squared. What do all those symbols mean? F means force, and force numbers are numbers that have newtons after them. So if I had something like 1,600 newtons, or 1.8 times 10 to the minus 2 newtons, that's a force number because of newtons. Okay? Q's are charges. When we put charges together, we already talked about this. When you bring charges together, we know that charges either pull or push away on each other, and that's what this force is. And those charges are the ones that create that force, that push or pull. So Q, they are charges, and they have numbers with coulombs after them. So if we had a number like 1.6 times 10 to the negative 6 coulombs, that would be a Q number. Okay? And then R is the distance between the charges. And just like magnets, if you bring two charges close to each other or two charges farther apart, they're going to have a different amount of force in between. If they're closer, they feel each other a whole bunch, and so there's a lot more force pushing away from each other, whereas here it's not very much. Okay? So the closer you are together, the more that force can feel. Okay? But be careful. We have to always understand that it's either going to be a repulsive force or an attractive force. So what is K? K is a constant number. It's a number sometimes added to mathematical equations in chemistry and physics to make numbers seem more realistic. So sometimes when you're having these 10 to the negative 6 numbers, the numbers are so small on their answer that you end up not wanting to use those numbers, or I should say they want those numbers to be more in a more normal range of like 1 to 1,000. So this number is used because charges are so small to give us more numbers that are easy to understand. So it's just a balancing type number. okay? But it is the same number, and it's added all the time to every problem, and it has 3 units so that the unit you want, whether it be newtons, distance, or charges, the other ones will all cancel out. So let's do a quick problem. Let's say we have a situation here, and we got this problem. Let's do one right here. Let's say we've got a problem where we have 2 charges. We have charge 1, Q, equals 2, it's negative 2.0 times 10 to the negative 4th coulombs. And we have another charge, Q2, and it is positive charge, 8.0 times 10 to the negative 4th coulombs. And let's say those 2 charges are about 3 meters apart. Okay, so we have these 2 charges, one is negative, one is positive, and the distance in between them is 0.3 of a meter, so about 30 centimeters. Okay, and we want to know what is the force that they are pulling on each other, because this would be an attractive force, so it would be a negative answer. Well, it's pretty simple. We're just going to use this equation. We want to solve for the force, so it's already set up. I don't need to rearrange it. Okay, and so I need to know the K number, which we told you already is going to be this number right here. So we just simply plug our numbers in. It is 9 times 10 to the 9th, and it's a Newton times a meter squared over a Coulomb squared. And really, this number is put out front, but it really belongs on top. But they put it out front for the problems itself. Then you just put your other numbers in. We have plus 2 times 10 to the negative 4th Coulomb. Sorry, it's minus 2. And then we have plus 8 times 10 to the negative 4th coulombs. Okay? And so we have Coulomb times a Coulomb, so they'll be Coulomb squared, and there's a Coulomb squared underneath. So if I just ignore that bottom part of the equation yet, I can see that these 2 coulombs will cancel out with those 2 right there. And then the bottom is r squared, so I need to square this number, so I'm going to go and put 0.3 meters, and I'm going to square it. But the units inside will actually get squared too, and then there's squared units on top, so this and this is going to cancel for the name, but I still have to square the number too. Don't forget about that. So you can see I'm going to end up with a Newton answer, which is correct. So now I just got to plug my numbers in, but don't forget to square the number and the unit. I put a line through it, but I don't want you to think it's gone. So on the bottom, we have the number. You can do that first if you want to or not. It's up to you. I'm going to show you how I do it. I'm going to plug in this number. Don't forget your power of 10 numbers. So 9 shift EE, so there's my EE, times 9, times, I'm going to just go across the top. And I don't need to put in the plus or minus. I know my answer is going to be negative overall because plus times minus. Okay, 2 shift EE, but I do have to put the negative 4 in for the power, equals times 8 shift EE negative 4 equals, so I've done the whole top of math. Now divided by 0.3 equals, and I'm at squared, so there's really like 2 of them. And then I'm going to go equals and push divided by 0.3 again equals. I do it twice, and I get an answer of 16,000. And that would be a force, so that would be newtons. So there's my answer. So that's the amount of force that would be felt, electrostatic force, between these 2 charges that distance apart. So real simple, okay? So just plug your numbers in, make sure you write a list. Q's are charges, R's are distances. You can find them by the letters after you know where they belong. And F is newtons, and K is the same number every single time. It never changes. Okay? So thank you very much for joining me. I appreciate it. Have a great day and blessings. Okay.